Welcome back to the Prairie Sun Timber series. I'm still Travis Brungardt with the Build Show, and today we're talking about our wall assembly. Now, in the background, you can see we've made a lot of progress, but I'm going to take you back through what it took to get here, because we have two very distinct and very high performance wall assemblies on this project. From the band board down, it's all zip system. We're using the Zip R exterior continuous insulated sheathing product, and obviously all the tapes and liquid flash that it takes to make that a very high performance air control as well as water control barrier. And of course, it's structural sheathing. But then from that rim up, it's all SIPs. That's your structurally insulated panels. We talked about that a little bit in the previous episode with the marriage of timbers and SIPs. So I'm not going to dwell a lot on the SIP itself. I want to talk about the Prosoco Cat 5 exterior WRB, the coatings that we put all over that. We really did a lot to make sure that we don't have any risk of moisture migrating into those SIPs panels. So that's what we're going to talk about in this episode. It's wall assemblies. We're going to talk obviously our zip system, obviously our SIPs and Prosoco system, but also our window performance. So stick with me and check it out.
Prairie Sun Timber, a Build original series, is brought to you by Prosoco, Enerlux Windows, and Timber Tech.
I'm Travis Brungardt with Catalyst Construction, but also the Build Show. And I'm standing in front of our Prairie Sun Timber project here in Kansas City. Now, Enerlux windows are what you're seeing behind me on this project, and we were thrilled to work with Enerlux on this project because of their extremely high performance packages for both windows and doors. Now, this is a fiberglass window product, and if you're used to high performance windows, you're used to seeing a lot of chunkier frames. That's something that our architects oftentimes don't favor. They like those clean, narrow lines. We want to give the maximum viewable glass, and that's what Enerlux provided. With U values down around 0.14, I've been thrilled with the performance on them. They're very quiet, air leakage extremely low, and then being sort of local to us, it kind of makes me feel like I'm supporting local, but they do service nationally. So if you're looking for a high performance window with low air leakage, really great triple glaze performance with clean lines and a very durable fiberglass frame, Enerlux might be a good choice for you. Welcome back to the Prairie Sun Timber series. I am so excited to have you here in Missouri, Matt. This is super fun to have you on the site.
I mean, could it be more exciting than this? This is one of the coolest things I've ever seen, Travis.
We're really excited about this project. It's been a lot of fun going through all the different details that we've put into this build, and you're the perfect guy to have out here for this because going back a few years, we're a little long in the tooth now. I was learning building science from you in my basement on YouTube back in the day, and now I get to do it in the real world.
Now you're teaching me. I love it.
Oh, maybe I'll show you a thing or two.
I've never done one of these, dude. This is really cool.
Really?
We got some neat stuff going on here.
All right, well, let's talk through it, because what we're doing here in episode 3 is we're really going to talk about windows and walls especially.
Yep.
But with everything, it's continuity of control layers, right? Like when we talk about this stuff with Steve, he's quick to break it down for us. Water's job one. As a builder, that's where all our risk lies.
That's right.
But this is our first SIPs build. And all the stuff that I read about SIPs, you know, I'm sure it's a very small percentage of the actual installs that have failures, but all the scary stuff that you get with SIPs has to do with vapor. And I usually downplay vapor risk. We use a lot of Rockwell vapor open assemblies, very low risk. This is not that.
No, this is a different deal.
Boy, your structure is that sandwich. So if you get vapor moving into that OSB panel, it can be dicey. So when Joe and I were asked to be part of this project, our client had already signed a contract with Timberbuilt to do the SIPs and timber frame. And Joe and I said, look, we're excited about this. We want to be part of this project. But the only way I would feel comfortable doing a SIPs project is with a really robust fluid applied system that can keep that risk mitigated. And that's what we did here with the Prosoco.
Okay, let me break that down real quick just to make sure I understand. So in other words, this Prosoco system, which does a great job of water management, also does a great job of air management. And you mentioned SIPS failures being from vapor. So let's translate for these guys how water and air translate to vapor. If there's no air movement through the assembly, then there's really very little risk of vapor traveling through and finding a cold condensing surface. So in Kansas, where it's easily 10 degrees on a winter day, right?
It can get down there.
The outside of this building, and especially the OSB that you see like at the outside of the SIPS panels, could be real cold, right? The insulation is inboard of that. Right. So if we had air traveling between, you know, let's say panels that are coming together, especially at ridges where some of the failures happened in the 90s, we could have this thing called ridge rot happen.
Right.
And it's a vapor issue, but it's also air that's transporting the vapor. So where those SIPS panels come together, especially at the ridge, but really anywhere around the building, if there's air flowing through that joint, it's very likely, especially on cold days, that there's going to be a cold condensing surface. And if water is condensing there, there's very little drying mechanism, because I've got this big sandwich of EPS foam with OSB on one side and OSB on the other. So there's not a lot of drying action, right? It's not like an old 1920s house that had studs and leakage and all this drying action. So Travis is saying to his client and figuring out, hey, I really want to reduce my risk as a builder, which is going to reduce your risk as a homeowner.
Right.
By making sure that we're really watertight, number one, which is our number one enemy,
Always.
But then really airtight. And if we take care of water and air, everything else kind of takes care of itself, typically, right?
Absolutely. That is our starting point, and everything after that, we can get better and better.
Yep.
But we've handled our risk at the outside.
Yeah.
And that's what we've done here.
That's
you want to come check it out?
Yeah, let's go check it out, y'all. Travis, I got to say, this big orange building with all fluid applied, it feels good. I mean, this kind of feels like a bed liner kind of material,
Yep.
like that really rubbery. It feels like screws and nails would gasket onto it. I like
Yeah.
it, man.
I tell you what, man, there's really nothing more bomber, as you would say, than fully encapsulating your assembly with continuous layer
Yep.
of air and water protection. And that's what we've done here, because honestly, when you think about where our risk is with OSB, it's in this stuff flaking off.
Yep.
So if we can seal it up, we can solve a lot of problems, and that's what we've done here.
Yeah,
This is a multi-step process.
As you mentioned, that flaking off feeling, you know, this Prosoco product and other fluid applieds, the chemistry behind this was developed in the 1970s by the Japanese in the auto industry.
Really?
And the original use for this type of chemistry, it's called STPE, silane terminated polyether, I think is the chemical term.
That, yeah.
It was intended as a windshield adhesive. That's what they were using. That's what they developed it for.
Okay.
And you think about glass being adhered to metal on you know, an automotive manufacturing line. It's got to be airtight and it's got to be watertight,
Yep.
and it's got to have adhesive properties to all kinds of things. You know, because glass and metal are not porous like wood would be, right? You can't use wood glue on glass.
Nothing to infiltrate.
So this is some pretty serious chemistry that went into this product a couple decades later now as a fluid applied for this building. And then that adhesive property is going to help you with that OSB to just kind of lock everything together.
100%. It's holding all this stuff together on a really challenging site as far as wind and water. We're up on a hilltop. There's a lot of exposure here.
Yeah.
And if you remember earlier, you were talking about builder risk. This is the kind of stuff that you see on commercial projects.
Yeah,
And
that's right.
if you think commercial, you think lawsuits and liability.
That's for sure.
And I don't want to see either one of those.
Yep.
So this was very easy for us to talk to our friends up the road in Lawrence, Kansas at Prosoco, because they, like everything that we do as builders, it's about the system, right?
Yeah.
None of this is, oh, I did this one part here and we tried something else over there. We're doing everything holistically.
Yep.
So for this, what we've done at every seam from one SIPS panel to another, that transition is first treated with their joint and seam filler,
Yep.
which is a little bit more fibrous. It's more like a toothpaste coming out of the tube. It's thicker, it's got body.
Yep.
And then you just trowel it down.
And so it's pink, and you can't see it now because it's been covered, but everywhere a transition happens, use joint and seam. And they tell you, Travis, that you can actually span up to a 3/4 inch gap.
Yeah, we
with
try
that.
not to have gaps like that on our builds, but yes, you can do it.
Which in the past, what I've done though is I've done some spray foam. Let's say if you had a pipe that came through or something, spray foam it so you've got a backer,
Right.
and then use the joint and seam on that. So all the transitions were pink. They're covered now, but they were pink first.
That's right.
And then what?
Then we go over that with their more elastomeric product, which is their fast flash.
Okay.
And you can see that, this darker red around our windows. That's part of the flashing system for all of the window installs.
Yeah, that's nice.
We actually have covered over that at the seams as well, and with the large membrane that you see, the big orange, and that's their Cat 5 product, which is either a sprayed on or a rolled on application.
And
so we're
what'd
not
you do here?
gunning it, we rolled it.
You rolled it, okay.
Again, high exposure, a lot of wind here, and this is a high solids material. So the pump that you need to spray this is not your Wagner, I'm going to shoot stain on my fence.
Right.
This is like a $9,000, $10,000 pump to push this product.
Yeah, it's real viscous. Your toothpaste example, it'd be like, could you spray caulking? Well, no, it's too thick.
Right.
So you need a big pump. And interesting to note that as you go from pink to red to orange, you kind of change to a lower viscosity.
Right.
It's more liquid, so to speak, as you go from those layers down. But this one still has some body to it. And so what was your method? Were you just dipping your roller in, or what were you doing?
Well, like I said, our first time using it, we got a little creative. We tried a few different things. We started with the paint grid and the 5, and you dip and roll.
Yep.
But we're going to talk about how we encapsulated this whole house. We started on the roof. I want to get water off this house as quick as possible. So we're top down. And I got to tell you, walking around up and down the rake, trying to dip and then go down and roll and dip and go down and roll and not drip where you're going to slide down the roof, it did not go well for us. I did not enjoy it.
Yeah, but that's right.
And so what we found was, the little backpack sprayers, like if you're going to blow weeds out on your property. I kind of MacGyvered that thing together. I got a build show episode on it. You're going to have to check it out. But
can't wait to see that.
Pulled the guts off of this backpack sprayer, put some plumbing fittings on, and then basically working off of harnesses and ropes, myself and Quentin, for the most part, I would distribute product through the sprayer that's not spraying. It's basically just dripping out, just through gravity, distributing product, and then Quentin's just back rolling behind me.
Oh, how about that?
So we found a very efficient means of getting the top of the roof done. But again, we're talking about a system in total continuity. One of the things that would be challenging in any build, when we want to encapsulate, we've got an OSB panel here that's nailed to the splines, or in this case, like a subfascia, to make up this 10.5-inch SIPS panel. So I've got joint and seam filler at this edge. I've got joint and seam filler at this edge, here. Very labor intensive.
Yeah, there's a lot going on.
But if you miss any step, that's where your risk happens.
Right.
So by taking it from the wall to the soffit and then up over the roof, all the way down around the other side, that's how we get continuity of our control layers, and that's how we can be effective as builders.
I have a word for that. It's a very technical word. Bomber.
I've heard that one before, and it's not wrong.
It's one of my favorites. I think I stole that from Christoph Irwin years ago, but I love that. I mean, when I look at this house, Travis, I think, dude, that is a bomber assembly.
It really
You
is.
have gone from the foundation to the ridge with zero break in continuity, and that's what this episode's about, is keeping that continuity. If you think about this house being a house wrap house, maybe even with traditional framing, there's all these breaks in continuity. And you have soffit vents, and you got all this other stuff you got to try and figure out, how do I connect this to that? On this one, you can walk up and know nothing about the building and go, wow, that big orange building is totally coated.
Yep. There's no easier system to attain continuity than a fluid applied.
Right.
It's just no folds, no weird fussy stuff.
Right.
Just goop, trowel, roll.
There are easier systems to install.
Sure.
And there's probably less costly systems, but I don't think there's any better than this.
No, not
I
for
do
this
have to ask you
application.
though, I've never seen Prosoco on a roof before. How is that approved? Like, what's going on with that? Are you going to nail shingles down on top of this?
Well, again, I told you I was leery of SIPs, and my thought is, as soon as we take a really good product and shoot a bunch of nails through it, it is losing something. And I was worried, in our market, we get hailstorms out here, at least once every 5 to 10 years.
Yeah, for sure.
So if I'm going to have the roof ripped off, and I got guys demoing a roof with rakes, popping shingles, we're going to have all those holes in what is the structure on this house. Remember, structurally insulated panel. This skin is it for me.
Yeah.
So that's my Alamo. So that was the other condition. I said, we've got to do an overroof. And I love a vented overroof.
Yes.
Wrote articles about it. I've spoken on it at trade shows.
Dude.
The idea of a ventilated overroof is so simple. And really, we're just doing what Stebrick does, right?
Yep.
The wall is the roof. Well,
Yep.
we put a rain screen on the wall. we're just gonna go ahead and put a vent cavity on that roof. We can let anything that gets in there drain out because I've already got my watertight layer here. And then I can also cool the backside of that roof with some ventilation and protect those SIPS panels, my structure in this case, from all the nailing and damage that would come with somebody demoing a roof.
Dude, that is money. So 100% Prosoco on the outside of the building.
Yep.
We're gonna put an over roof on with some 1x strapping and then a layer of zip system sheathing, which I can tape quickly and be waterproof right away. The other thing that's gonna do, Travis, is keep the UV rays off this because we don't have an unlimited UV time with this product. We got it covered up. So that over roof is gonna put this all in the shadows and the UV rays will not touch it anymore. Dude, this is a bomber assembly.
We're gonna talk more about the over roof and our rain screen in episode 4.
Okay.
But in this third episode, I really wanna focus on not just our walls, but our windows. So why don't we go ahead and do a quick window install? We can talk about that. And then you mentioned earlier this all wrapped. There is actually a section of my house that is not wrapped in Prosoco, and I want to show you that too.
All right, let's go set a window. We'll meet you over here. All right, Travis, fiberglass, and why fiberglass? Let's jump in here. And by the way, Travis and I have both been building, coming up on 30 years from me. So over our 60 years, I've literally put in just about every manufacturer's product. I started with all vinyl when I was in my production builder days. The last 20 years as I've been custom building, I kind of throw the baby out on that material, to be totally honest. I've not installed one in 20 years. But fiberglass compared to, let's say, wood or another composite material, what is it about fiberglass that we like particularly?
Well, it's a couple things. For us, it starts with strength. You know, as an electrician, I spend a lot of time on a ladder, and I trust my life to the support that I get out of fiberglass day in and day out. So you know you got a lot of strength with it. It's very stable. We're not looking at a lot of movement. And then that really ties into the assembly as a whole. You know, building science side of things for us, we're always looking at assemblies, and all your problems are at transitions. So if I transition from one material to another, that's a risk. We could have differential movement. A seal could separate. We don't want that in a window, but I've got glass framed with fiberglass. It's the same material. They're not going to move at different rates.
So they're going to expand and contract at the same rates. And I don't see glass expanding and contracting a whole lot on my jobs. Do you?
No, sir.
You know, another note, as we're thinking about that fiberglass ladder on the job site, you're an electrician. If that ladder were to somehow fall on an electrical line, you wouldn't get electrocuted because the fiberglass is non-conductive, which also makes a lot of sense when we think about a window frame, because we don't want that heat or maybe cold in the wintertime to conduct into the house as well, right, Travis?
Yeah, that's the beauty of it.
So it makes a lot of sense as a building material and specifically a window frame material. Another thing that I want to talk about, Travis, is construction of fiberglass. So, you know, when we think about wood windows, we could maybe glue that wood together. We think about a lot of screws or mechanical fasteners. But when we think about fiberglass, what is it about fiberglass, and how specifically are we going to join that material?
Well, I mean, different manufacturers do it different ways. We're talking about complex assemblies usually. Sometimes you have things that lap or interlock. But in order to keep things, as a trim carpenter as well, keeping things tight, that's what the client sees. And it's not just about what's visually great, it's the performance aspect of it. If that joint stays closed and nothing gets into it, now you've got good performance. So that assembly, on this, I was shocked at how this is put together. This is pretty cool.
Yeah, so check this out. I don't know if other manufacturers are doing this, but this is specific to Enerlux, and this is really cool. What you're seeing here is a corner sample. So the main kind of length or body of the fiberglass is a big stick, right? And when they miter that and put these two corners together, this rail and this rail come together, we got a nice tight miter, but there's no screws on the backside. There's no glue per se. What they do, Travis, is they drill a hole in the frame and they fill this entire corner with a urethane. It kind of, to me, looks like a two-part epoxy, but it's slightly different chemistry than that. It's a urethane, more akin to like a super crazy closed cell foam in some respects in this corner. And if you could feel the weight of that thing.
Oh, that's like a pound.
It feels like a lot of material.
Yeah, there's some heft to that.
So what that's doing now is it's gluing that entire corner together. It's making sure that miter's never going to come apart. It's also making sure there's no air or water that could make it into that assembly as well.
Yeah, it's a very robust assembly to be sure. And what I really like about it is if you can view across that, look how flush that is. When you have like a metal piece of hardware behind that you have to match screws and fasteners into, you can have a little bit of deformation. You know, as you pull that screw tight on this side, it can pull this side over and you can get that joint a little bit out. This is dead flush, dead flat. It's really robust.
Yeah, I like that. Now, I don't think that if you're considering fiberglass, you're probably considering vinyl as well. But maybe you're moving up, right? Every builder's got to start somewhere. Yeah. One really nice thing about fiberglass that is a much stronger material, which means that you can get a much thinner frame profile. If you look at some of these Enerlux windows that have been installed already, we had a big builder meeting out here yesterday, and one of the builders said, hey, those windows look like steel windows. What is that material? Because they've got that real thin frame, because that fiberglass is a naturally very strong material. And especially as you get into bigger windows, if you're not building out of fiberglass, you think a lot of times about big chunky frames, and that's not the case here. I like that.
No, we're getting really good performance out of a really narrow profile, and that gives the client what they want, which is the big view of light. That's why we put the windows in after all.
Yeah, that's right. Now, Travis, you're really known for doing super high efficiency. You know, you look at this house behind me, you'll have to check out his other videos. This is a bomber house. But you didn't do the standard double glaze. You actually upgraded to triple glaze, right?
100%, man. We're building such, as you pointed out, high performance wall assemblies that we're delivering super high R values and great comfort to our clients. But if you cut short on what would be the worst R value in a wall assembly, that's the window. That's where your client's going to feel that discomfort, and that's where your complaint's coming.
Yeah. Now, here's something about Enerlux specifically that I think is really interesting. This is a corner section from kind of a standard double glazed window, which would meet code in pretty much every market in America. Enerlux does something a little bit differently. They take a much thicker, a 3.9 millimeter glass, and if you look at these two up close, you can tell it's quite a bit thicker for their double glaze. And not only that, they put a fatter spacer in there. So I think you're going to get much better sound performance out of a window like this compared to some of the competitors that are kind of using standard glass. But back to that triple glaze real quick and fiberglass before we actually go in and show you those numbers. Another analogy on fiberglass that I really like, Travis, that really speaks to me is, you know, when you think about boats and something that's going to be in the water for its lifetime, a lot of boats are made out of fiberglass, because that fiberglass is totally impervious. There's nothing that we're worried about in terms of water soaking up. It's not soaking up any water. So these windows, like, you've got pretty good cover on this house, but like that tall window is probably going to get
exposure. It's
going to get some exposure. And now we're not worried about cladding it, right? If we had a wood material, we're always worried about, hey, what's the cladding on that window to make sure it's protected from the elements. This is fiberglass through and through because we're not worried about that water.
Yeah, and you get a tremendous amount of stability with that as well. You know, again, it's that differential movement. If I've got wood inside and I got to wrap the outside with something that's more robust, that's an opportunity for things to move differently and a potential failure down the road. So all fiberglass all the way through, that negates that risk.
Yeah, for sure. Now, have you used Enerlux before this install?
I have not. I'm sure you know this about me, Matt. We talk a lot about trying to do what we can with our local manufacturers. That gives us some flexibility. If there ever was a problem, I can call somebody, I can go get it. All that stuff, you see that on our projects all the time. When we were researching windows for this project, we were really pretty excited to discover that just up north of us in Crete, Nebraska, just outside of Lincoln, Nebraska, that's where Enerlux makes their product. And so, I mean, we even had guys from the plant come down, show off their stuff to us. It was a really nice hand in glove for us, where we're supporting local and we're getting a really great product that, frankly, I was shocked that we were getting domestically produced performance on this level. So it was an easy choice.
That's pretty cool. Speaking of performance, let's actually jump inside real quick and let's look at a couple details inside, and let's see what the window sticker has to tell us about the performance of this window. We'll see you inside. Travis, we mentioned outside how one of the builders specifically said, man, those frames are nice and thin.
Yeah.
And I think it was this picture window that he was like, man, those look like steel windows to me.
There really is that narrower profile, like 1.5 inches.
That's pretty thin. But what I wanted to talk about when we jump in here is the window sticker. I've talked about this a bunch over the years, but these window stickers are a little hard to understand for builders out there, and certainly for homeowners. They're like, I have no idea what that means.
It's a lot of numbers.
So let's translate. You know, this U factor that's on here, is an overall, the glass, the frame, it's meant to say how much insulation basically does this window provide.
Sure, what's its performance?
And I like to teach people the numbers on this because I think it makes a lot of sense. So before we do this window, let's talk code real quick. Do you know what code U factor is here for this area?
Oh, I don't. We build so far above code I never watch.
It's probably 0.32
okay.
would be my guess.
Yeah.
So if you do the math on your calculator, 1 divided by 0.32 is 3.125. That's the overall R value to meet code for a window in this climate, and that's actually code for my climate as well. So in other words, this U factor on here is basically needs to be divided by 1, and that's how you get the R value. And I like to talk R value because people understand that, right?
Yes.
You know, I've got an R13 bat or I've got an R21 bat. We get a sense for insulation. So this is kind of a side note, but what's your rough R value walls on this house?
We are 22.6 above grade. We are 26.8 for our walkout condition.
And that's not just the bats in there. That's
No.
that's a whole
Effective
wall
R
value. This is actually a SIPS project up, and then he's got zip R down with some rock wool. So these are really big R values. So my point here is, if we were to put a code built window or a window that meets code in here, which you could do, right?
Right.
It's going to be a bit of a difference, frankly, a stark difference between the walls and the windows in terms of how much heat resistance is coming through the walls.
Yeah.
So Travis, being a high performance builder, said to Enerlux, hey, I actually want to upgrade to your triple glazed window. Right. And let's do the math on this sticker. So this is a picture window. Typically picture windows are going to be the best insulation value. You're going to be a slightly higher number on an operable, but this one says 0.14. So the math on here on my calculator is 1 divided by 0.14. That's an R 7.14 window. I'm not so much interested in the absolute R value as I am to say relative to a double glazed window or a code built window. This window that Travis installed by Enerlux is twice as good, twice as insulative. It's going to hold back twice as many BTUs of cold getting into my house, or really my BTUs leaving the house, right? Which I think is really interesting. Not necessarily in how much am I going to pay back over time in terms of energy saved, but I can tell you, when your client's sitting here,
it's the comfort.
When it's 10 degrees outside, this window is not going to pull the heat off your body like a double glazed window would. And I think that's a big advantage to Enerlux, because it wasn't much of an upcharge to go to these, was it?
No, I know a lot of times when we have this conversation historically with clients, we're like, well, we'd really like to do triple glaze, and clients, they were watching the budget.
Yeah.
We have historically watched them shrink back from the table when we say triple glaze, because they're thinking triple price.
Right, or double price.
Right, and that's not even close to what this was. That was like a 15% increase to go with the triple glaze glass.
Yeah.
And especially here in the great room, where this wall is mostly glass.
Yeah.
Money well spent. Money
well spent, for sure. And for a 15% upcharge, no brainer. We haven't really talked cost. It's always hard to talk exact cost. Right. But relatively speaking, this is a very affordable window, really high performance, and not much more to go to triple glaze.
Yeah, and after the cost factor and the appearance, the other thing that my client was kind of wowed by, can I show you? There's one other thing they were really excited about.
What do you got? Yeah.
So I don't know if you've seen this before. This was the first time I've seen this. So you noticed in the very narrow profile, there's a small groove. That's what receives the screen. What Enerlux provides us with their screen is this flexi screen product.
Oh, I've seen this at the builder show before. I've never seen one in the field before, though.
But it's a spring steel frame. It's super narrow.
Oh, man.
The screen product is adhered to it directly, and this is the only screen that can fit into this window. But I'm sure you've dealt with those screen frames, big aluminum extrusion with a metal clip that snaps down and they break.
I do not like them.
And if you've ever had to clean windows, I can't imagine an easier system than pull it, fold it away, and then just set it right back in.
So there's basically like a U channel in there that it fits in, and you just flex it in and drop it in. That's pretty sweet.
Super durable, but still they offer a lifetime guarantee on that.
Lifetime guarantee?
Lifetime guarantee on the screens. Now you got to pay them for the shipping. If you really had a dog, chew through one or tear it up with claws, just reach out to them. I think they said it was about $13 shipping for a new screen.
It's not bad at all.
But the screen is covered. So
that's pretty cool.
That's a fantastic product. The lady of the house is very excited when we showed her the screen. And I was excited too because I'd never seen it before.
Impressive. Guys, I think we made a pretty dang good case for fiberglass and specifically some really impressive features about these Enerlux windows. We still got 2 or 3 windows to set.
Let's do it.
So guys, prep. What's our first step?
So as always, we're thinking about water. And so we've already done to 4 inches into the window so that we can have continuity of air control after the fact, because we'll come back with air dam on the inside of the window.
Okay.
But we've got to have continuity. So that's why the fast flash goes in further.
Yep. And it also goes in at the sill, the jambs, and the head.
Exactly. But now, since Joe already placed shims in our mole location and our edges, the supporting locations for the window, we're really ready to start applying this at our sides and head.
All right.
We do not apply it across the bottom because if any water does get into the system, we want to leave an easy path out.
All right, let's do it. Go for it, Travis.
You go up first and then I'll come up.
And I'll be the stabilizer. How about that?
Okay. All right, we're going bottom in first. And I'm set.
Yep. Okay, so that bottom's in.
You good, Joe?
And again, there's nothing on the flange down here at the bottom.
Correct.
And we're gonna see a little bit of squeeze out on the back side. You can see it right there.
Okay, I'll stay in the middle.
Joe is going to make sure this window is both level and plumb. This happens to be a fixed window, so where there's a little less concerned about action, but in general, we would put a screw or a nail in one of the bottom corners so that the window's tacked. Then we'll shim the window to make sure it's level, and then we'll double check it's plumb, and then we'll screw it off on the flange all the way around.
So Matt, we've screwed off every other hole in the installation flange, and we're really ready to go ahead and apply the fast flash over the flange to get our continuity.
Okay, so as Travis finishes this up, the next step is going to be to go to the inside because we need to connect that window to the rough opening from both an air and a water continuity perspective. So let's cut to the inside and we'll show you the last step in the process. What Travis is going to do is he's going to now take the continuity between the window and the red and pink that you see here, which we put on earlier. That made a good water and air barrier for the framing. And now this air dam is going to connect it. I like that name. It kind of gives a flavor for what it's doing. It's stopping air with a back dam on the back of this window. Now, if we had a bigger gap than this, we'd want to put a backer rod in here, but this is a pretty tight gap. And my main sausage caulking gun guy right here, Travis, is going to show you the process. It's really straightforward. We're basically just back caulking the window. There's only so much to talk about here. It's really pretty straightforward. The big key though is if you have a bigger gap, you want a backer rod. And I would say actually this joint that he's doing here is on the verge of needing a backer rod.
I could use a 1/4 inch there.
You could use a smaller backer rod, but that's okay. And we're not filling the gap, right? What we're trying to do anytime we're on a bead of any type of caulking is we want it to touch on 2 sides, but not the back side of the joint. So if you picture a U shape, we want that caulking to touch both sides of the top of the U, but not go the full depth. So all he's doing is connecting the window frame to the Prosoco joint and seam or fast flash, the red material that's on there. So all Travis is going to do basically here is run around the whole length of the window. But I think it'd be worth us mentioning that you did not strike down that joint.
Right.
You certainly could have. You could have put a rubber glove on, struck that joint down if you wanted to. You don't need to though. You've got trim on here.
Yeah, we're gonna have jam extensions that come in. They're gonna completely hide all that. So I would rather not risk smearing sealant on my window or more importantly, degrading that air seal. I wanna leave the solids where they need to be.
And it was a tight joint. Had we had a wider joint with a backer rod, the fluid applied guys who do this all the time, I actually have a set of them back in my toolbox, make these spatulas in different sizes. They basically just look like fingers in different widths. And so we could get the correct finger for the width to strike down that joint. And that would make sure the sealant is touching the window frame and the jamb, and on the backside, the backer rod, but not going the full depth of the cavity. So
that would produce that ideal hourglass sealant shape where you've got contact both sides and it can elongate.
Exactly.
We're not going to have a lot of structural movement at our window.
Yep.
I think that's less critical in this application, but you're absolutely right. That's best practice. I want to take you inside and go over a couple of things on our thermal continuity.
Okay. Man, this walkout's nice on this job. I like it.
All right. I wanted to bring you into the basement first because, as we talked about, it's all about continuity.
Yep.
So in episode 1, we talked about how we do our rock wool on our foundation walls and under the slab that we're standing on now.
Absolutely beautiful. Textbook install.
I appreciate that. We work hard on that stuff, so thanks for noticing.
Well done.
I wanted to also talk about, as we walked across the back of the house, you probably noticed we weren't that orange box all the way down.
Right. Your zip on this bottom section,
Right.
which I'm assuming means we're all standard framing down here.
Well, yeah, as Steve calls advanced framing, it's framing.
It's framing.
We are 24 on center with our 2x6 walls for our down walls. And this is a walkout condition that allows the clients to really view up this draw, which is just beautiful pastoral Midwest prairie grasses and trees and deer and the whole deal.
Beautiful.
So this is fantastic. But when we started on this project, there was a little bit of a, let's just say, some confusion of discontinuity because the SIPs and timber build condition upstairs is not something they offer for this. They said, you get me a floor system and we'll build you. It's like, okay, so I do the floor, I do the down walls. And he's like, yeah, and you do the garage. It's like,
So in other words, this is just foundation as far as they're concerned.
Exactly.
But it's not really foundation, it's framing.
Exactly.
So it's an interesting hybrid. You've got real traditional framing, I-joists, you know, zip sheeting, some steel to hold up. This column's holding up a
that big 10 by 10
piece of timber above us.
Yeah.
I figured that was the case. So how does that work, and how are you keeping that continuity?
Man, that's where the challenge was with this build because you're partnering with someone that isn't necessarily your regular partner. You know, you work with the same trades all the time. So do we.
Yep.
We've got trust and we've got a really nice hand in glove with those guys. But this, the client had already hired the timber frame, and that contract was separate. So I had no, I have no oversight on them other than, hey, I'm the builder. I'm telling you this is what I want done.
Sure.
They were very nice. I don't have any issue with the guys. Great crew. The install crew was fantastic. We'll talk more about that when we talk more about the Prosoco outside. But what I wanted to point out here is that when Joe and I start looking at, hey, we're building this house with SIPs upstairs, that's a 22.8 R value in that wall assembly. We've got to at least do that or better for our stuff. If we're going to build it, I don't want to have the worst thing on the house. So Joe and I started figuring out this assembly, and
22.8, that's a high bar because that's not cavity insulation, right? That's whole wall rated effective.
Yeah, effective R value.
How'd you get there then?
Well, I'm glad you asked because we take a lot of pride in our assemblies, as I know you do as well, and we typically build with zip system. So when we got to this point, I said, well, we're certainly going to do zip R, but how much R are we talking about?
Right, because they've got an R3, an R6, an R9, and an R12.
That's right. And the 12 is usually where people go, whoa, 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 because it takes a special nail that takes a special gun. And now all of a sudden your framer, who's quick and easy on everything, is like, wait a minute, are you going to buy me a bunch of equipment? Because that's more work for me. So we stopped just short of that. We pushed to what we consider the practical limit. We went with the zip R9. So we have continuous exterior insulation that gives us a very similar thermal break and excellent performance, which is what we have upstairs. So what I want to make sure we do for our clients is always deliver the best possible outcome, same as you. And that's what we were able to do here. 24-inch on center, 2x6 walls, Rockwool R23 in cavity, and then zip R9 to the exterior. So in between, I'm actually R32 from cavity to exterior. And then at every stud, obviously I've only got 5.5 R value for my 2x6. So I'm really only 14.5. But that's less than 15% of my opaque wall section is that 14.5. So I did my math and I thought I came out pretty much R28. But you know, our friend Randy Williams that's presenting at Build Show Live. Randy's really sharp.
Northern Built Pro on Instagram.
Fantastic resource. I texted him and I was like, am I doing my math right? And he says, well, here's how they taught me to do it at BPI. You convert everything to U value, then you convert everything back. It was a lot of math gymnastics that I was not interested in doing. He said it's only 26.5, but that's still That's still better than 22.8.
Good. Wow, that's high.
And it allows us to work with our traditional systems. So
And
our
you
framers
bought this all at your local lumber yard.
got it right up the street.
Yeah.
So that's why we were so excited about sharing it, because when you get to the opportunities of these new technologies, and for us, SIPs was a new technology.
Yeah.
There are things that can be really scary with that.
Yep.
But we can solve these problems with the Prosoco over the top.
Yep.
I can solve this. Hey, we got to do a partnership. We need walls and floors to start our SIPs assembly. And we can do that with our local framer, our local building products, and we can still deliver that great performance.
Yep.
So that's what I wanted to talk to you about in here.
Huge, man. This is really well built.
I
Very
appreciate
impressive. And it comes back to me saying sometimes the old ways and the old systems, but done in a new way, can be just as good as fancy bleeding edge technology.
100%.
And we're not throwing shade on anybody here.
No.
We're just saying that good old fashioned smart builders can build a heck of a good building if you let us.
That's right. It's sometimes not the tool, but the guy who's got the toolbox knows which one to pull out.
This is the best tool you got right there.
You got
That's
it.
why these clients hired you.
So if I've got these really robust and awesome performing wall assemblies, and then we're going to put a bunch of holes in them,
Yep.
what do you think I want to put in the hole? Something that's equally high performing.
Yeah.
So let's talk about these windows.
Okay, let's do it.
Come on out. All right, Matt. What we've got here for our windows and walls, we've got to match that level of performance, right?
Yep.
We talked about that 22.8 R value upstairs on the
huge
SIPs.
R value.
And down here with my, we'll call it 26.5 to keep Randy happy, but I'm still going to claim 28 because that's the math that I did. This window, we're going to deliver extreme comfort with this triple glazed window.
Yeah.
And I don't have any durability concerns either because this is that all fiberglass assembly. They do that injected corner with the 2-part polyurethane.
That's really nice.
It's really strong and everything lays out flush.
Just on an aesthetic note, I like the black in the because it's fiberglass. They have a thin frame.
Oh, yeah.
What's that frame width? I'm curious.
Dude, it's only 1.5 inches.
That's such a nice profile.
So that's our great window package. Everywhere on the house, any window you see through, it's one of these Enerlux triple glazed
That's nice.
with this high performance. And then what I wanted to talk about here is we've got this zip integral membrane for our water and air control here. And so that made it very easy for our timber framer to set these brackets.
Right onto the zip.
Right onto the zip. It's already got that continuous layer.
That's nice.
I gave them a gallon before they started setting anything else. I said, you got to put Cat 5 on any bare OSB SIPs panels before you put my brackets on, or there's no way I can make up the continuity.
So like that bracket up there, which has the orange around it, they had to roll on
They
the
rolled
orange
first.
Cat 5 first, set the bracket, and then you came back and were able to kind of roll onto that.
That's right. And that's the value of a general contractor because they know every step and they work backwards and they catch it before it's a problem.
Nice. That's nice. Textbook install, by the way, on this Enerlux window.
Oh, man.
Beautiful. Stretch in the corners, tape for the rest.
Yep.
All that continuity runs inside. And then how will you connect the inside continuity?
Well, down here, we're doing mostly traditional stuff like we talked about inside. So we use backer rod and big stretch. That creates a perfect air control layer there.
Yep.
It also provides a sort of a physical back dam because
Yeah.
we don't usually do a back dam detail.
right. Yeah.
Now upstairs, again, we respect systems. There's a lot of money that goes into R&D for this stuff.
Yeah.
You know that.
Yeah.
So Prosoco has a system. I'm not going to introduce new products. We can put air dam from them. It's their version of that same solution. It's backer rod, and that's how we're going to have our continuity upstairs. I always want to be respectful of the system.
Smart.
And this is the best fit for us down here.
Yeah, I like that.
Now, I got to point out, I've got a reverse lap here, and I know that someone's going to get me in the comments and be like, did you see that reverse lap? We've talked on a lot of podcasts about self-terminating tapes. And so if you want to learn more about that, you got to check out Matt's videos, listen to Unbuild It podcast. Or,
There's a lot to talk about
There's
there.
a lot there. But you can see the nailing. For the Zip R9, we've got a different nailing pattern.
Yeah, you gotta really bump it up a little bit.
Yeah.
Because that nail's doing some of the shear help.
100%. It's a little bit larger diameter nail for some, or a different pattern. For us, it was 3 on center at the perimeter, and then we ended up at just 12 in the field. So
Yeah, by the way,
we follow
almost
the dots.
perfect air control on your gun. I mean, like these nails are like the perfect amount sunk. It's
We
very
have a few
impressive.
shiners out there, a couple proud, but those are not going to be a problem for us because we've got it still tight to the membrane, and we're going to rain screen this.
Yeah.
In the next episode, we'll talk
Oh, you're
more
gonna
about
rain
that.
screen this? Yeah,
Yeah.
your money.
Which helps us a lot because you can see we have a little bit of an out of plane condition here. Again,
you do,
because
just a hair.
we're doing part of it and the timber framers doing their SIPs. Well, when they
Right.
set their first panel, they were a little bit out. I went off the longest straight wall in the front when we built the floor system. So we're square to that. They squared to their first panel set and they got a little off track. I can make all that up in my rain screen.
Yeah, so if you're using a rain screen here, well, we don't want to tease you, but come back for that episode and he'll
Yes,
show
sir.
you how to make that up. There's a couple of tricks of the trade, so to speak, from a smart carpenter to fix that.
That's right.
And then as we come around the corner, we've got some continuity here that's an issue too, because you've got a foundation wall that's holding back the earth here.
That's right.
And you had to transition here and keep that continuity. You want to talk to me about that too?
Yeah, this is another one of those, hey, Steve Brick keeps it simple. We do the same thing, a wall in the vertical, in this case, is exactly like our horizontal detail there. So I have a mud sill, big stretch adhered to, and that's why we have the term barrier there. And so, again, we have that double plate condition. So I have a stud right behind here that's allowing me to secure to the foundation. But our air control continuity is with the big stretch. Our water is all through the taping. And then, obviously, we've got some splash back here. We're going to wipe this down. And just because it's cheap and easy to do, we'll caulk this too.
And then how will you cover this corner of the building? Is this going to get a metal cap? Will you put a siding cap on there?
The clients are still determining their final finishes for this. There's a lot of talk of, well, we're going to do some hardy panel. We had some metal. There was some brick for a while.
Gotcha.
Until they decide, I'm not going to say for sure, but my guess is that our siding, because we're going to build this out the rain screen anyway, I'm going to build this out with a piece of trim, and all of our field siding is just going to move across that.
Smart.
No problems.
Yeah, then you won't see that at all.
I think the last thing to point out back here before we wrap this up is you immediately identified, hey, we've got a big piece of zip tape here. I want to just mention the reason that that's there is because, again, I'm respectful of systems. That is the top of my zip panel.
Yep.
But before we even taped any of that stuff, we already did the joint and seam filler at the bottom of the SIPS panel.
Nice.
And then we fast flashed it, and then we Cat 5'd it, which is why you can see some of the roller of the Cat 5 down on the
You've
zip.
got a belt, a suspenders, and an elastic waist.
That's right. A top hat and a monocle and everything, everything in one. But that's the whole reason that wide panel of tape is there, because I've got to do zip system for their warranty and to make sure that I've done what they told me to do.
Yeah.
But I also have to do what Prosoco tells me to do, and we want to make sure those materials are compatible, and they are. It's a really nice hand and glove system there.
Yeah, that's really nice.
That's my windows and walls, Matt. That's episode 3 of our Prairie Sun and Timber series.
Travis,
I'm really excited to have you here.
Man, this is a really cool house. And to drive up for the first time and see that big orange box, I was like, dude, this is gonna be awesome. What a cool episode, man.
It's really great, and it's great to have you be a part of it. Thanks so much.
Man, you do great work, Travis. Really glad to be here.
Thanks, brother.
Very, very fun.
So that wraps up episode 3 of our Prairie Sun and Timber series. Again, this is sort of the 2-part look at our exterior control layers, where we're really dealing mostly with water and air. So in this episode, we pretty well covered what we did with our zip system, as well as our Cat 5 above grade, that Prosoco system all the way up over the roof. And that's what I'm teasing with the next episode. We're going over the roof. We're going to talk about rain screens and all that. So you'll definitely want to come back for that. But just a little excitement to share with you, which I think will integrate a little bit into the episode. We were able to get a really nice blower door score using these 2 systems. So if we look at the Prosoco Cat 5 and really the bomber nature of fluid applied, as Matt would say, that fluid applied system on the SIPs coupled with our WRB integrated into the panel on the zip system itself, and then the taping, and then looping in our windows from Enerlux, we were able to achieve a 0.56 on our first blower door score yesterday, and now we get to work on it to make it better. So you can see that in addition to managing water, we're delivering exceptional air control and what's going to be a really tight house that's going to perform for a long, long time. Come back and see us on episode 4. Thanks for watching.